This is the apocalypse we aren't talking about. Like many of you probably think of the end of the world as being some kind of nuclear holocaust or global pandemic, something along those lines. Well, actually, it's much more likely that the next apocalypse will be magnetic. And while it might sound kind of sci-fi, this is something that has happened before and will happen again. It's just a fact of life here on Earth. You see, our planet is wrapped in a giant protective bubble of magnetic energy called the magnetosphere, which is generated by the movement of our planet's molten iron-nickel core. This is what's known as a geodynamo, and these are pretty common among planets and other celestial bodies. In fact, if a planet doesn't have an active core, it'll lose its magnetic field and its atmosphere very quickly. Mars is a good example of this. Its core is completely solid, so there is no longer any significant magnetic field, and it's lost most of its atmosphere over billions of years. The Earth, however, has retained its magnetic field for billions of years, and in doing so has retained a very hospitable atmosphere that we humans like to live in. But that could all change in the next million years or so, when our planet's magnetic poles flip. Now, this isn't going to be like the North Pole suddenly becoming the South Pole. It's not even going to happen overnight. This is a process that takes hundreds or even thousands of years to complete and happens gradually. But it is a process that must eventually happen because our planet's magnetic field is not constant. In fact, it changes over time. The magnetic field flips are thought to have started at least 800,000 years ago based on analysis of magnetic minerals in ocean sediments. These reversals have always been random, occurring every few 100,000 years, although they're not quite regular. They can happen faster or slower than that, and scientists can tell where each reversal started based on the rocks in which the magnetic field was recorded. Each rock has a different magnetic signature based on where that rock was located when the magnetic field passed through it. So scientists know that the last flip began in the Atlantic Ocean near the island of Bermuda. It appears that the next flip is already underway, but it's happening in the Pacific Ocean, south of Tahiti. And based on past behavior, it will take around 240 years to complete, meaning it should be finished sometime in the year 2260. Now, there is some uncertainty about exactly how long it will take, because the rate of change is accelerating. It's expanding at 10 degrees per century now, but it may increase further. This is because, as the magnetic field weakens, the solar wind can penetrate the magnetosphere more easily, making the weakening worse. Now, when scientists say the magnetic poles flip, they're referring to the Earth's magnetic axis. The axis is the line that runs from the magnetic North Pole to the magnetic South Pole. When the flip occurs, the axis tilts over and then reorients itself. And while that sounds relatively benign, it can cause some major problems. As the magnetic poles shift closer and closer together, the magnetic field becomes more unstable. Auroras can appear much lower in the sky, and magnetic storms become more frequent. In fact, during the Lascaux magnetic reversal, about 780,000 years ago, the Earth's magnetic poles came so close to each other that there was basically no magnetic field for about 500 years. And right now, we're on track for something similar. At the moment, the magnetic poles are 11 degrees apart and getting closer. When they meet, it's called the magnetic equator, and it's essentially a zone of chaos. The geomagnetic field lines converge at this point, making it a massive cosmic radiation hotspot. And as the poles get even closer, this region of space expands. So it's easy to see why every single living thing on Earth would want the magnetic poles to slow down and stop moving. But there's another big problem too. You see, besides protecting us from harmful cosmic radiation, the magnetic field also helps to drive weather patterns. It's part of what's called the Earth's atmospheric circulation system, which includes winds, ocean currents, and even the jet stream. It works because the magnetic field drives a current in the ionosphere, which causes electric fields to form in the lower atmosphere. Those electric fields, in turn, drive winds that circle the planet in both directions. And if that weren't enough, the magnetic field also influences the way heat is distributed around the planet. In the upper atmosphere, charged particles bounce off of the field lines, transferring energy that heats them up. That means that even though the Earth receives the same amount of sunlight every day, different regions receive different amounts of heat due to the angle of the sun and the way the magnetic field channels and distributes energy. In other words, the magnetic field is helping to regulate our climate as well. So any significant changes to this system could potentially throw our planet's climate into chaos. In fact, researchers have found evidence that the Lascaux magnetic reversal caused global temperatures to rise by as much as 9 degrees Celsius. Even though the Earth had been stuck in a cooling trend for 60,000 years prior to this, there was an abrupt halt, and temperatures shot up before returning to normal a few thousand years later. Could something similar happen again? It's possible, but really it's impossible to say. There's not really any consensus on how the magnetic pole flip will affect the climate. Most experts seem to agree that there will be some impact, but how much of an impact is anybody's guess. We have seen that the Lascaux flip did cause rapid climate change, but that was during the Pleistocene epoch, which is a period of intense glacial activity. Our planet was already undergoing huge shifts in temperature and precipitation, so it's hard to tease out the effects of the magnetic flip. Plus, the modern world is a lot more sensitive to climate change than it was back then, because we rely on stable weather patterns for food production and to support large populations. So while a 9-degree spike in global temperatures might not sound too bad, that sort of rapid change today would have devastating consequences. And those aren't the only problems associated with the flip. You see, besides driving atmospheric circulation, the magnetic field also drives ocean currents. This is because salt water is electrically conductive, so it picks up the electric fields generated by the magnetic field. This causes deep water currents to form that play a crucial role in regulating ocean temperatures and mixing nutrients. And just like with the atmosphere, these currents affect weather patterns all over the planet. For example, the Gulf Stream carries warm water from the tropics toward Europe, keeping the continent warmer than it should be given how far north it is. But during magnetic pole flips, the currents can weaken significantly. One study suggests that they could slow down by as much as 60%, which would lead to major disruptions. So yeah, a magnetic pole flip would have some pretty serious consequences. It would expose us to higher levels of cosmic radiation, destabilize the climate and disrupt ocean currents. But here's the thing. This is something that has happened many times over the course of Earth's history, and life has found a way to adapt every time. I mean, sure, some creatures like the dinosaurs didn't make it through, but life on the whole did. And chances are it will continue to do so. After all, it took 100 million years for oxygen levels to recover after the Great Oxidation event, when photosynthesis first evolved. Yet life still managed to thrive. After all, there were animals bigger than whales swimming around in the oceans and giant insects crawling around on land. Similarly, the extinction event at the end of the Cretaceous wasn't able to stop the radiation of mammals. In fact, it helped to set the stage for our own evolution. In other words, despite the fact that major environmental shifts like these have happened again and again throughout history, life always seems to find a way to survive and even thrive. And that's why scientists are hesitantly optimistic about our ability to deal with whatever comes our way. Take, for example, the Younger Dryas, a period of rapid climate change at the end of the last ice age. In less than a century, temperatures rose by 2 to 3 degrees Celsius. That's equivalent to the warming we've experienced over the last 20 years. And that kind of drastic change happened 12,000 years ago, when humans were still making cave paintings and hadn't invented agriculture yet. So obviously we're better equipped now to handle such a scenario. Yes, there would be challenges, but humanity has a good chance of surviving. Some species wouldn't be so lucky. If the magnetic pole flip does cause temperatures to rise by a few degrees, for example, the vast majority of species that live in the Arctic would go extinct. But even so, this wouldn't be anything new. Since the beginning of the Pleistocene epoch, at least 11 major mass extinctions have occurred, and it looks like there's a good chance that the 12th will happen soon enough. The good news is that humanity could actually benefit from all of this. As we enter a new geologic era, we have the opportunity to start over and build a better future for ourselves. There's a reason why the young people of today are so hopeless. If they grew up expecting that things would continue to improve, only to see temperatures rise and extreme weather events become more frequent, they might become pretty pessimistic about the future. But here's the thing, as bad as things may seem right now, they could get a lot worse. So if we can make it through the next magnetic pole flip, I think we'll be able to make it through anything. Thanks for watching. If you enjoyed this video, be sure to subscribe for more. Thanks to my supporters for making these videos possible.